At 1033, Chapter 3, Section 4, still dealing with functions, but this is dealing with slope. All right, first of all, slope is represented by the little m. It is rise over run. It is also y2 minus y1 over x2 minus x1, meaning you have to have two ordered pairs. Sometimes you'll see this delta y over delta x. Delta means change in, so this is change in y over change in x. Make sure you understand. If we have a positive slope, then the top is positive, so is the bottom. So it causes us to move whatever the top number is up, the bottom number to the right. If we have a negative slope, the top number is negative, bottom number is still positive. This is an easy way to do this. So with the negative slope, we go down for the top number, we go to the right for the bottom number. Some examples. Here's example 2 in the book of calculating the slope. You have the point 5, negative 4, and negative 3, 3. Notice they label 5, negative 4 as x1, y1. Negative 3, 3 is x2, y2, so that they put the numbers in the right position. Notice also that in the formula, you have a minus sign in the formula. So whenever you're subtracting a negative number, it becomes a double negative, so you add. So this becomes 3 plus 4, which is 7. Negative 3 minus 5 is negative 8, so this becomes a negative 7 eighths. So this would tell us we would go down 7 and to the right 8. And that's exactly what they do here. They take the point negative 3, 3. As you look at it, they've gone down 7 to the right 8. That's how they get the point 5, negative 4. Example problem 4, which you're going to encounter, is where you get a equation in standard form. Where standard form is where x and y are on the same side. What you're going to do is use algebra to get it in slope-intercept form. So the first thing I did here was subtract the 3x over. That's how I got negative 4y equals negative 3x plus 4. Then I divided by negative 4. Negative 3 divided by negative 4 is a positive 3/4. Positive 4 divided by negative 4 is a minus 1. Now I'm in slope-intercept form. Slope-intercept form tells me that the number with the x variable is the slope, so we have a slope of 3/4. The minus 1 at the end tells us that's the y-intercept, so it's 0, negative 1. Do not put b equals negative 1. I will mark it wrong. Your y-intercept, your intercept, is in an ordered pair, and it should be written as an ordered pair. So, elaborating on what we talked about in the last section, here's example 6 in your book. Basically what this is doing is it's giving you an equation of x equals negative 5. Anytime I get x equals a number, it is a vertical line at that number on the x-axis. So you can see in my graph here, negative 1, negative 2, negative 3, negative 4, negative 5. Draw my vertical line. And one thing you got to know about this is anytime I get x equals negative 5, the slope is undefined. The reason the slope is undefined is because the ordered pairs all have the same x. I've demonstrated that here. And if I plug it in the slope formula, what happens is the bottom x's cancel out, give me 0 on the bottom, and anytime I have 0 on the bottom of a fraction, it's undefined. Same thing holds true. Here's example 7 with y equals a number. If I have y equals a number, it's a horizontal line going through that number on the y-axis. The slope is always 0. Here I've given the points in this particular, in y equals 2, or y equals a number, the y's are always the same. So here I have negative 4, 2, 3, 2. If I put it in the slope equation, I find out that the top cancels out, gives me 0 on the top. Anytime I have 0 on the top of a fraction, I get 0. On example 3 real quick, I'm not quite sure why they're doing all this math right here. Question says, find the slope of the line whose equation is f of x equals 2/3 x plus 4. Well, if it's in slope-intercept form, the question's pretty easy. Slope is 2/3. Y-intercept would be 0, 4. I have no idea why this is going on. This is example 5 in the book, and I just want to go over it a little bit just to show you how it's used. It says the adult one-day pass price, Y, for Disney World is given by the equation Y equals 4.07x plus 66.4, where x represents the number of years since 2006. So what this equation is saying is that in 2006, the price for a one-day pass was $66.40. What it's also saying is by the slope that the price of a one-day pass is going up $4.07 every year. So if you look at this, it says use the equation to predict the ticket prices for 2021. Well, if 2006 was our starting point, which is right here, then if we subtract 2006 from 2021, we get 15. So we're going to stick a 15 in for this x right here, do the math, and get our answer. And that's exactly what they did here. Stuck 15 in there, multiplied by 4.07, added 66.4, so in 2021, a one-day pass should be $127.45, which is pretty close to being accurate if I remember what the price of a one-day pass at Disney is. You can also read here at B, it says, what does the slope of this equation mean? We've already discussed that. It means $4, and the price of a one-day ticket is going up $4.07 every year. C says, what does the y-intercept of this equation mean? $66.40 was the price of a one-day pass in 2006. Another page, which is on page 161. This is a good page because it shows you the only 4 types of slopes you have. You have a positive slope, which rises from left to right. You have a negative slope, which falls from left to right. A horizontal line, which is y equals number. Vertical line, which is x equals number. That's the only 4 types of slopes that you have. Relationship of slopes. We have 2 relationships. Parallel lines, the slopes are always equal. Same sign, same number. Perpendicular lines. Slopes are opposite in sign, which means one's positive, one's negative. And the reciprocals, which means the denominator becomes the numerator in the other number, the numerator becomes the denominator in the other. I'll give you an example here. If I have negative 1/3 and the lines are perpendicular for a slope, then the other slope is 3/1. Opposite signs, reciprocals. Another way to do this is that if I multiply these 2 slopes together, perpendicular lines, if you multiply their 2 slopes, will always give you a -1. Come to example 8, we've got 2 problems here. Give us 3x plus 7y equals 4, and 6x plus 14y equals 7. I've labeled 3x plus y equals 4 as equation 1, 6x plus 4y equals 7 as equation 2. Wants to know if these lines are perpendicular, parallel, or neither. So what we did was we took equation 1, subtracted 3x over, divided by 7. We got y equals -3/7 x plus 4/7. Take equation 2, subtract 6x over, divide by 14. Reduce fractions, we get -3/7 x plus 1/2. Because the slopes are the same sign and the same number, the lines are parallel. Remember, parallel lines will have the same slope, sign and number, but different y-intercepts. Second example here, equation 1 is -x plus 3y equals 2. Second equation is 2x plus 6y equals 5. Again, we use algebra to put the standard form of the equations into slope-intercept form. First equation, we get y equals a positive 1/3 x plus 2/3. Second equation, we get y equals -1/3 x plus 5/6. These equations are neither parallel nor perpendicular. First of all, even though they're the same number, they're not the same sign, so they're not the same slopes, so they can't be parallel. Even though this is opposite sign, this is positive, this is negative, they're not reciprocals of each other. And if we were to multiply this, we get -1/9, so they're not perpendicular either. Very, very important question. Understanding the relationship of slopes of perpendicular lines and slopes of parallel lines.